Search is broken, and we thought AI search was going to fix it. But AI search is just as cumbersome to use. Search engines have prioritized speed and have cut back on curation and quality of links. And this is the problem we're trying to fix today. We are trying to build a better search experience to learn stuff, and we are going to use OpenAI's reasoning models, DeepSeek's reasoning models, and a whole lot of agents to build the best learning experience search engine. Let's get building. Let's take a look at the state of search in the current search engines. When I want to learn about a topic, how does the experience look like? Let's start with Google, the biggest name in search. When I want to learn about a topic, let's take the topic, teach me about climate change. When we start with Google, the interface is simple. We have an AI overview in the very beginning, and then we have some organic results on the back. This, according to me, is the worst experience in search among all the options I'm going to show you today, just because the AI overview doesn't do much and it doesn't take up a lot of real estate. It doesn't help me learn the topic of climate change. Bing Deep Search. Bing uses the similar AI search kind of concept. It does a little more summarizing and curating, but it still doesn't give me a very pleasing way to learn the topic. The next one we'll go through is Perplexity, which has made its bread and butter in AI search. Perplexity touts itself as an answer engine. I asked the same question to Perplexity. It's given me a nice view to look at UI-wise, but again, same thing. It's really meant for me to just consume the information in one go, but not build the information in my head. All of these search engines kind of focus on speed. The last one I want to show you is actually ChatGPT's AI search, which I think is decent, but it still is lacking in some stuff. I am using ChatGPT's latest models to do this AI search. So you can see it gives you a good description of what climate change is. It adds some links there. But again, to me, the links are not really full-fledged, and all of them almost always kind of are Wikipedia-ish. But I wanted to kind of spread its wings a little bit. I want to find more videos. I want to find more books, etc. for these things. This is where the search experience is in the current state. And I wanted to kind of bring about a search experience that's a little more pleasing to look at, something that puts information in an order of operations that's very easy to understand, and something that will allow you to upgrade your learning experience from a novice to an expert. We built DeepSearch.Guru. This is an experiment to see if we can build a better Perplexity or an answer engine using reasoning models from OpenAI and DeepSeek, and also using agents to collect the data that you typically would Google search for. DeepSearch.Guru puts it in a very easy to understand manner, and we're calling this way of putting data together as chronological knowledge building. We'll talk about why we picked this way of categorizing data and summarizing it, and it's more scientific than you think. It puts all the information in a chronological manner. It adds a lot of links to each piece of information, things like books, videos, Wikipedia links, articles from outside. So it's got the full gamut of information. And the best thing is it can switch between light and dark mode and different models. And my favorite option of all, you can download your results and view them offline. Let's take a deeper look at why we are choosing a chronological ordering of events and explaining a topic. So I wanted to understand a basic concept. Every time I wanted to learn something, I felt like I learned it better when I was in Wikipedia rather than Google searching it. And the reason is multiple things. I liked Wikipedia's kind of focused approach of me looking at text. I liked the way it built chronologically on different topics and events. And I also learned how it kind of collected links in each reference point that I can kind of link out and see more details on what that. I wanted to also understand why Wikipedia's way of structuring data helps me understand things a lot better. Went to the O1 model and went to a lot of back and forth with it, trying to understand what the science behind that is. I've linked it in my article, but essentially it goes through a lot of research, etc., to break down the concept in a very interesting way that our brain works just like how we've trained these foundational models, right? Like, and the genesis of machine learning neural networks is scientists wanting to learn how the human brain functions. So what it's doing here is very similar to how these LLMs kind of also learn. They are able to correlate these topics and put them in context to each other. And while doing that, research shows that the brain kind of retains more memory of the topic itself. I've linked the whole thing so we can kind of break it down a little more on your own speed. Now, having gotten to the point where I am understanding how I want to structure my engine, let's go into how I built my engine. My tech stack to build my engine is this. I used Replit to build my framework. I used Copilot and Claude Sonnet to help me with my coding. I used OpenAI and DeepSeek reasoning models to help me with the brains of my operation when I ask for a topic. Then I built some simple AI agents to go enrich my content once I had that. So this is my tech stack, and this is how I built this better learning engine. Let's start with Replit. To give everyone a quick context of what Replit's new AI agent does, Replit's new AI agent helps you kind of build quick proof of concepts or quick apps in a very easy way by giving it some prompt. Again, I want to like stress on one thing. One part of doing this exercise is also me trying to learn how good these AI agent / coding agents are, like Replit, Cursor, etc. And also to learn what makes them tick and what makes them kind of have an issue and so on and so forth. For me, my findings, we'll talk about my findings on Replit at the end of the video. Let's start off with setting up our Replit and setting up our framework for what we wanted to. What this will do is it will quickly develop a structure and a framework for your app that you can then get more intense and do more targeted coding for.
A few moments later.
Let's break down the UI for our app. I wanted to keep it simple. I wanted to keep the interface very close to what Google's is, but I wanted to add a couple of things. Pick different models. In this case, I wanted to switch between OpenAI and DeepSeek. And then B, I wanted to definitely have what these current search engines don't have, a dark mode. I wanted to understand how I can fashion results and curate them. And this is where we took some of our learnings from our reasoning that we did with our O1 model about how to use a timelined structure or a chronological structure to help you better memorize or remember or understand the topic. I wanted to add a little bit of inspiration for users when they come in. So we are adding a trending section. This Perplexity also has it a little bit, but what I wanted to do here is keep it more inspirational. From Google Trends, we get all the topics, and then it passes through the AI. The AI kind of then takes all the topics and categorizes them into different categories, and also picks out learning topics that it can learn from. For example, there is a news article about certain Rebecca Loback trending. The learning topic there is Rebecca Loback. Let's dive into the UI of the results page. I wanted to give the user some sort of status while different activities are going on in the background. Here, once I hit the topic, it goes to my reasoning engine. My reasoning engine understands the topic. It picks the best way to represent the topic for the user in a chronological manner. And then once it does that, it then sends all the topics of the chronological manner to the different agents, and the different agents collect information and bring it back. A very important thing is that the different agents' results that come back are then processed again through the AI so that irrelevant and unnecessary or hallucinated kind of links are taken away. All of this is then distilled together and put under one simple interface. Two different boxes here that explain what the topic is. I wanted to keep a simple toggle that kind of makes a more simpler explanation of the topic itself. And then I also wanted to show some detailed explanation just for people who are more interested in getting that level of detail. Topic deep dive view. Here we go with the chronological way of explaining quantum physics. And this helps users understand a better way what quantum physics is. So we go through the different kind of learning topics for quantum physics. We always want to have like one which the future trends, like how the future is trending, just because you want to know how things are going to be moving forward. And then in addition to all that, I wanted to also let users take this result set out into the real world. I want them to be able to keep it, save it, use it anytime they want. For example, if you needed to do a project work on quantum physics, you'd want all these details, but you also want it saved so you can quickly go to it. So I provided a way for users to save their data and open up as a PDF with links in the PDF still active that they can click on and learn more. So this way they can get like a quick summary of their results, and also it'll give them a good way for them to save their links for future. Let's look at how the code is built now. In trying to build this to use both DeepSeek and OpenAI, my biggest learning is that DeepSeek is very easy to build if you've already built an app on OpenAI. All you have to change, because DeepSeek is just using the same library that OpenAI is using, is the base URL of where you're pointing to. Now, this may not be best practice. You're just piggybacking on your biggest competitors' API libraries, but it saves them time and effort in trying to re-engineer all of these URLs and packages and libraries on their own. As you can see, we are setting up. So this is how we've set up a connection for both DeepSeek and OpenAI with the same code base. This can be used across the board in different applications if you want to switch between models, but especially with DeepSeek and OpenAI, it's a very easy case to make to keep it the same code base. All right, let's look at a couple of examples here. I want to walk through the different models that we're using here. We're keeping it as a Boolean because we're keeping it the toggle. What we're doing here is giving the concept of what we're trying to do for that topic. We're giving some details on how many things to add, how many things to not add. This gives the details so that the next part, which is the AI agents part, have some context on what they're doing. For the AI agents part, same thing as the previous. You want each topic to have multiple links and related links to it. So we're kind of using some advanced algorithm. So I'm using some extra algorithm of foundational, intermediate, and advanced difficulties, trying to mix it up a little bit so that users get a very streamlined way to understand topics. Then we are actually gathering all the resources from these different agents. Here we have Wikipedia agent, Google Results agent, YouTube content agent, Google Books agents, and so on and so forth. All of these are gathering the links and details. And then what we're doing at the end, and this is the most important thing that I felt kind of made the search results a little better, is I wanted to go through the effort of kind of doing a quality check at the end before displaying it to the user. So we're doing another quality check at the end with all the links so that some of the links which didn't make sense can be taken away from the... All right, so this is how the agents are built. Now that we've gathered our agents, we've gathered our OpenAI and DeepSeek code. By the way, all of this is open sourced. I will put the link to the GitHub on my video. You can fork it, use it as you please. The best thing about using tools like Replit and Vercel is that deployment becomes very easy. Deployment is almost baked into the experience where you can choose reserved VMs or autoscale your app. Most cases, this can be done for as cheap as $6 a month for a reserved VM with zero point 0.5 CPUs. And then you go ahead and start your deployment. You give some build command, run commands, and that's it. That's all you have to do, and it maintains everything on its own. All right, so what did we learn from this exercise? We learned that converting OpenAI code to DeepSeek code is relatively easy. I learned that Claude's Sonnet model, the 3.5, is still the king of coding. I learned that Replit and so called AI assisted coders, AI agent coders, are not as good as they're advertised to be, but they're really good at building you a framework of an app. Meaning you don't need to worry about what the project structures need to be, what the file structure needs to be, where you need the index, where you need the app.tsx, nothing like that. So it'll do that stuff for you. All you need to do is it'll build all the hooks and connections. All you need to do is get more advanced into the coding of the app itself with a little bit of help from GitHub, Copilot, and so on and so forth. What we've also learned is that search engines today are not fine tuned to help you learn and understand content better. And that to build your own app and host it, it doesn't take much, but it takes some persistence. Thank you. I hope everybody enjoyed this video. If you like my content, please like, share, subscribe, and make sure you go fork the code and do your own experiments. Take care.